For our next segment, we are going to talk about a time period called the Scientific Revolution. The Scientific Revolution takes place in Europe primarily in the 16th, 17th, and 18th centuries. It was a big movement that defined the turning point in which people would get information primarily from the church and Aristotle's ideas, which the church had borrowed, to people finding information by themselves. Before this, people would answer questions that way. If people had questions about life, nature, and about the ways things worked, people would go to the church, and the church would very often default either to the Bible or to ancient Rome and Greece. During this period, people began to emphasize this idea of reason. They would find the answers to things based on their observations, science, and what was taking place around them, systematically looking at problems and answer questions to those problems based on what science was telling them. So the time of the Scientific Revolution was when people would look for answers not so much through the church, but they began to look for answers to nature through reasons and through scientific observation, as we largely do today.
There were 5 theories, or 5 discoveries, that took place during this time that revolutionized people's thinking about the natural world. The first one was a Polish man named Nicholas Copernicus. Copernicus comes along and he introduces what is called the heliocentric theory. The heliocentric theory was the theory that the sun, rather than the earth, was the center of the solar system, and that the earth, as well as the other planets, revolved around the sun. This was very different than what people had thought before. Before, people thought that there was a geocentric theory, which was that the earth was the center of the solar system, and that the sun went around the earth. It's very logical that they would think that, because from standing on the earth, it looks very much like the sun does revolve around the earth. In fact, we still say things like, the sun is rising in the morning, when in fact, that the sun is stationary, and we are the ones going around the sun. How did he figure this out exactly? He figured this out through scientific observation and through reason, not just through things that have been accepted for thousands of years at this point.
The next major thinker was a man named Kepler. Johannes Kepler comes along and he talks about planetary motion. And he said all the things that Copernicus said are in fact true. That the sun is the center of the solar system and that the planets do go around the sun. But what he noticed as he looked out, again, through scientific observation, he noticed that the planets actually moved in ellipses and that they weren't actually moving in perfect circles, but they would be moving in almost like an oval type of pattern as they revolved around the sun. So he is known primarily for his studies of planetary motion.
Our next major thinker, who you've probably heard of already, is Galileo Galilei. He went generally by Galileo, and what he is going to do among many other studies that he did during his life is he is going to invent a better telescope. Now, he's not the first person to invent the telescope. That would be Hans Lippershey. But he does make a telescope that people can use to look up at farther away planets to see what goes on beyond the Earth, unlike Hans Lippershey's, which is very short-ranged. The importance of this telescope that he invents is the fact that with his telescope, he looks up and discovers proof that would help support what both Kepler and Copernicus had been attempting to prove in the years before.
Along with Galileo comes a man named Isaac Newton. Isaac Newton is going to revolutionize thinking about science. He's going to totally shake things up. People believed for a long time that the Earth was in one specific sphere. There were certain rules of Earth, like if you were to have dropped a ball on Earth, then it would fall. And there were certain rules for outer space. So the sun, the moon, and the other planets had their own rules, and that was why they never fell to Earth. That they were two completely different spheres. What Newton comes along and says is that that is simply not the case. He says gravity, or the pull that two bodies have towards each other, is actually universal. That what takes place in outer space is exactly what takes place on Earth. The only thing that affects the pull of gravity is the distance between two objects or the overall mass of the objects. So basically gravity is universal. So Newton came up with this universal theory of gravity.
Our fifth and last discovery, or major thinker, is a guy by the name of William Harvey. Harvey is actually the only one of these 5 men who's going to make observations not in the area of physics or astronomy, but rather in the medical field. Harvey's going to basically say that human beings have a heart, and that the heart works as a pump, which basically circulates oxygenated blood throughout your body. This discovery revolutionized the way doctors looked and treated the human body, and becomes the basis for further discoveries in the medical field.
We have many important outcomes of all these ideas and discoveries. First, we have the increased emphasis in the world on reason. In other words, if someone says the water in the ocean is blue, then we right away look for a reason in that. What is the reason ocean water is blue? We know today it is a reflection of the sky and how light rays affect it. Back at that time, people would make up answers for things they didn't quite understand. How do we know that? We know that because of the systematic observation. We go through and do all kinds of experimentation through our next outcome, which is the scientific method.
Our next important outcome of this time period was the introduction of the ideas that would develop to what we would know as today as the scientific method, which was created through the ideas of Francis Bacon, who introduced inductive reasoning, and René Descartes, which introduced deductive reasoning. Deductive reasoning says that you should use general truths to find out other truths. Inductive reasoning is the idea that you should use observations alone to find truths within the world. It's no longer acceptable to say that something is the way it is because God made it that way, but you should be able to systematically observe and explain your answers through what we would call the scientific method.
The last important outcome we have of the scientific revolution is just the enormous expansion of scientific knowledge we see during this time period. People began to view the world in a very different way. They view the Earth not as the center of the universe, but one of many planets that go around the sun. We begin to produce new theories and new inventions to test these theories. And this leads to us being able to make a giant leap forward in our understanding of physics and biology. The scientific revolution was a significant time period of knowledge that changed the way people saw society and nature.
During the Enlightenment, we see huge changes in the world in terms of the way people view government. For a long period of time in the world, there was a king, and his job was to rule over those people. No parliament or legislative branch of people to help make the rules fair or just, and if they did exist, they were usually overruled by the king. He could make any law and everyone would have to follow it, except for himself in most cases, because of the king's power, which was absolute. So these kings were known as absolute monarchs. But where do they get this absolute power from?
It was believed that they got their absolute power from God above the king. The kings would refer to this as their divine right of kings. Now, in the 1700s, we begin to see a period of time known as the Enlightenment.
People began to question the concept of the king getting their absolute power from God. One man we know who supported this concept was Thomas Hobbes. He comes and says that people are basically two things: evil and selfish. People make bad decisions, and because people make bad decisions, they need kings to rule over them and tell them what to do.
Then came along John Locke. Locke said that the idea that Hobbes has about people being evil and selfish is not true. He believed that people were born into the world with 3 natural rights. He said these rights were life, liberty, and property. John Locke said that because people are born with life, liberty, and property, that they know when those rights are violated. He said that the job of the government was to protect the 3 natural rights.
Next came a thinker named Montesquieu. Montesquieu had said, what if the same government that's protecting your natural rights uses its power against your natural rights? He came up with the idea of separation of powers. There should be an executive branch, legislative branch, and a judicial branch of government. The 3 branches of government would share and be able to check each other's power to keep it balanced. The government would still be able to keep its power, but separate it into these 3 sections.
Then came another thinker, Rousseau. He is going to state that the government is actually a contract. Rousseau said that a contract between government and the people is a social contract. He believed in the same idea as Locke in that the job of government was to protect our natural rights, and if the government does anything besides that, then the people can back out of their contract and make their own government. Last of the Enlightenment thinkers is Voltaire. He focused heavily on the idea that government needs to separate from the church. So basically, he believed in religious freedom. Now he wanted there to be a separation of the church and government so that there is greater tolerance in society.
The Enlightenment gave many countries ideas about how government should be run and how civil rights were made. But unlike most other reforms of the time before it, it allowed for reason and improvement. There was no one right way, nor one right reason, but multiple. This period influenced the American and French revolutions in achieving their goals.